In question 29, you are actually doing a titration between potassium hydroxide, which is a strong base, and ethanoic acid, which is a weak acid. So the question is asking you to select a statement based on this titration, and it is relating to endpoint and equivalence point. Okay, so to answer this question, you need to recall back your knowledge on the titration curve, which you can see in this diagram here, for a strong base and weak acid combination. So as you can see, since potassium hydroxide is in the conical flask, the starting pH of your curve will be very high. And as titration is carried out, or as the neutralization reaction is taking place, the pH will initially start to reduce until it comes to a point where the next addition of one drop will cause a steep region in your curve, whereby there will be a drastic pH change. It is here in this steep region where you will find your equivalence point and also the end point. So if I were to write the neutralization reaction for this titration, you would have ethanoic acid, since it's a weak acid, and potassium hydroxide will be in ions, since it's a strong base, and you are going to get the salt, an ethanoid salt, and water. Okay, your equivalence point, whereby the stoichiometrically equal amount of acid and base has been added, would be basic for this question, because your salt produced, sodium ethanoate, is actually a basic salt. If you remember salt hydrolysis, ethanoate ion undergoes hydrolysis reaction, producing ethanoic acid, and there is a release of hydroxide ions. Due to the production of hydroxide ions, the equivalence point for this titration combination would be basic. Okay, so that would mean I have to use phenolphthalein, which is the correct indicator. But the question has stated that methyl orange was used. So take a look at methyl orange endpoint, which is actually in the acidic pH range. Furthermore, the methyl orange endpoint is outside the steep region of the curve. Why is it so important for endpoint to and equivalence point to be in this particular region of your titration curve? Is because we want the endpoint and equivalence point to occur simultaneously. That would indicate the neutralization reaction is complete and your indicator will change color at that time. So in this case, if you were to use the wrong indicator and methyl orange was used instead, your titration or your neutralization reaction will still proceed, whereby once the equivalence point has been reached, there will not be a color change. But upon addition of more and more acid, that is where you may see a color change happening, if at all. So what's going to happen here? You are going to choose your answer, which is C. The end point of the titration would occur after equivalence point. As you can see here, you're going to pass the equivalence point. No color change is going to happen. As you keep adding more and more acid, that is when eventually you may see the end point taking place. So this is the statement for this question. But always remember, if you have chosen the right indicator for the titration, your endpoint and equivalence point should happen at the same time.